We want to find all these solutions. What is the degree of the polynomial? 3. So we will have 3 solutions. Does it factor? Doesn't look like it. It probably does in a way that we don't yet know. So what are the p's? P's are factors of 4, so good. 1, 2, and 4. What are the q's? Those are factors of 3. 1 and 3. At this point, we must list the factors, or the choices. You take each one of the p's and divide them by each one of the q's. So I'm going to go 1 over 1, 2 over 1, and 4 over 1. So I have plus or minus 1, plus or minus 2, plus or minus 4. Now, I'm going to take 1, 2, and 4 and divide each one by 3. So plus or minus 1/3, plus or minus 2/3, plus or minus 4/3. Okay, B. Rodden, let's tell us a little bit about why you do not like this. Say it. Starts with an F. Fractions, right? You hate the fractions, right? Okay, you loathe fractions. You reserve hate for things like the Holocaust. I get it. But you loathe fractions. Like, you would rather have your fingernail pulled out with the pliers than to do fractions. You know what? I'll show you this problem does involve fractions, but it's not going to be a concern for us in the least. I'm going to try 1. Does 1 work? Yes, it does, because I get 3 plus 10 minus 9 minus 4 is equal to 0. So, since 1 works, that means x minus 1 is a factor. So I will divide the polynomial by x minus 1. I will use synthetic division because it's awesome. I divide. I get 3, 3, 13, 13, 4, 4, and 0. Well, we have 1 factor. And now, the resulting polynomial is of what degree? It's of the second degree. We have 2 ways to solve second degree polynomials. What are they? Very good. Or just factor. So, quadratic formula, complete square, or let's just factor it. So, no, you were 100% correct. You were right. You use the quadratic formula, and you do complete the square, and those are valid options here. I would just rather factor. How is this factor? Good try. 3x plus 1, x plus 4. Sorry, YouTube. We have somebody in classes doing voodoo math right now, but they don't see it, and so we're gonna let T. Ravis help them out. So, okay, we've got solutions of x is equal to 1. So, did we end up with a fraction? Did we have to plug the fraction in? No. So it's not so bad if we end up with fractions. Shh. Now, before we move on to the last example, please pay close attention to this, because this is where I get frustrated on the test. I teach you to know that there are 3 solutions, yet here's what you do. You write down 2 solutions. You write down -1/3 and -4. Which one did you miss? Why did you not write down 1? Because it was at the beginning. So make sure that you list the 3 solutions. Make sure that there are 3. Then, an excellent mathematician always has a way to try to verify their answers. And 1 is one of my choices. -1/3 is one of my choices. And -4 is one of my choices. So, again, that doesn't show that it's for sure correct. I could plug each one of those in and verify it's correct, but at least I have a quick way to check to see if I'm on the right track. Flip it over. What's different about this one? Degree 4, yep. So Q's are just going to be 1, but what about the P's?
1, 2, 3, 4, 6, 7.
Very good. So Lolly sees that we've got a lot of P's going on here, and we're going to have to write them as plus or minus for our choices. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, 6, 8, 12, 16, 24, 48. Okay, well, what do you want to start with? Okay, so 1 would be 1 plus 7 is 8. Say it is 16. Yeah, not going to work out. You want to try 2? Okay. All right. Yeah, let's just do 6 to the 4th. Let's try 2. So 2 would be 16. Plus 2 to the 3rd is 8 times 7 is 56. And then 2 squared is 4 times 8 is 32. And then minus 56, and then minus 48. And so, deep inside, there's parts of this that you really love. And this is one of the neat parts that when you plug this in, you find quick ways to zero it out. Those cancel, and then 16 and 32 will cancel at the negative 48, right? So 2 worked. We're going to hold on to that one. So we've got x minus 2 as a factor. So I'm going to take 2 and divide it in. It's also because I'm pretty good at math. I'm giving you guys time to get caught up. Oh, I get it. Those of you who weren't here yesterday, you don't remember the synthetic division. You do. Okay. Oh, way to go. Star quality responsibility. All right. So I divide it and I get a cubic. Now, as we go back to our decision tree, you see that you have this situation. We identify the number of roots. It was 4. It didn't factor, so we use the rational roots theorem. We did our P's and our Q's. We used substitution final that 2 worked. We divided it by the factor. And then was our new polynomial, is it of degree 2? No. If it was, we would use a quadratic formula or factor or complete square. If it's greater than 2 for a degree, we start back over. And we have to then ask those questions. But there are some things that we can eliminate pretty quickly here. First of all, 1 and negative 1 did not work, so we can eliminate those from our choices. Second of all, our last number is 24, so what else can we eliminate? 48 and 16. We'll pretend you didn't say 3. And now we can get rid of half of the answer or half of the choices that are up there. We could get rid of all positives. Why, Lauren? Since they're all positive, there's no way that if we plug in a positive, we're going to get 0, right? So instead of trying 2 again, let's try negative 2. If you plug in negative 2, we get a negative 8. Negative 2 squared is 4 times 9 is 36. Minus 52. What's 24? And you can see that the 36 and the 24 make 60, and then the negative 8 and negative 52 make negative 60. Sure enough, it makes 0. So negative 2 works. So what's my factor? X plus 2. So I'm going to take the negative 2 and divide it in. And since I've seen a couple other people work these out in class, I just want you to know that when I get to a third degree and I found something that divides it evenly, I'm pretty happy because I'm home free now. Because I know I'm going to come up with a second degree, and when I do that, that's going to be easy to solve, right? So, we're basically just about done with the problem. So you drop the 1, -2, 7, -14, 12, -24, 0. So looks like this does factor to x minus 2 times x plus 2 times x squared plus 7x plus 12. So my new polynomial is of degree 2. Does it factor? Yes. So I have x minus 2 times x plus 2 times x plus 3 times x plus 4. And so my solutions are 2, -2, -3, and -4. And you can see that they are located up here. A +2, a -3, a -2, a -4, and I have a total of 4 solutions. And we could sketch the graph pretty easily, couldn't we? In fact, because I think it's so much fun, I am going to quick sketch the graph. 1, 2, 3, 4, 1, 2. Crosses at -4, -3, -2, and 2. And the graph looks something like that. With a y-intercept, we even saw it in there, is going to be -48, isn't it? I mean, we've got a pretty good idea of the graph. So, pretty awesome, huh? So, here's what we're going to do. You have the rest of the hour to work. I have a couple things for you. Number one, to your assignment yesterday, I forgot, in previous years, I've had them also graph all of the problems. I just want you to focus on graphing 28 through 31. So there's no really addition to your assignment other than to focus on graphing these.